Welcome to Saravji. Today's topic is an educational talk about feature selection and feature engineering and why it matters. In this part, I'll cover feature engineering. So why feature engineering? One reason could be to actually equalizing the signal strengths between features to establish an equal importance between the features, so that not one feature is overly domineering or one feature is inappropriately of lesser importance simply because of the different signal strengths. Another reason could actually be to amplify signaling features. Another reason could be creating an abstraction of a timeless meaning of features to allow a comparison between past configurations and current configurations. So this way, because we are creating an abstraction, we make things that appear not to be directly comparable, we make them comparable by means of that abstraction. Then we could be creating an additional amplitude or a specific distinction out of existing features. We can create additional dimensionality, or we can reduce dimensionality. Is feature engineering necessary? More often than not, the data that we work with has features that have an implicit meaning that, of course, is very easily understandable for us humans. But the machine learning algorithm is not going to be picking up on these, at least not yet. So it is important to actually complement this implicit data with explicit features to actually enable machine learning algorithms to utilize this information. And feature engineering, by these definitions, is a vast field, and what you can do in feature engineering is literally limited by imagination. It's not possible to cover an exhaustive number of the possibilities that could be there. So in the next few slides, I'm going to be going over a few very basic approaches to feature engineering and a few ideas that can be used as always available and easily available starting points. Feature engineering is necessary because if an important feature is not presented, it can't be fitted by the machine learning algorithm. If one feature dwarfs other features with its numbers or its number range, it may actually dominate the fitting of the machine learning algorithms, so the other feature would not be appropriately considered. Then there's also the possibility that a signal is barely noticeable, so it might not get picked up at all. And then if the meaning is implicitly hidden within the data, but it's not extracted, a machine learning algorithm can't pick up on it. So how can we approach feature engineering? An intuitive approach, or intuitive approaches to feature engineering are, for example, normalizing or standardizing features to actually eliminate range imbalances. And so, for example, a house price forecast, we're looking at number of bedrooms versus square foot of house. So we could standardize here, and then abstracting features to counter drift over time. Prime example is hard drives or SSD in laptops. a few years ago, 128 gigabyte hard drive was sufficient. These days, you don't even get it with that kind of storage anymore, or barely. Another example could be stock prices after a stock split. So that we're actually abstracting the features, abstracting how stock is behaving, and that we are creating an abstraction to compensate for the stock split, so that we can actually compare prior to stock split to post stock split behaviors or patterns in the stock prices. And then we can amplify values to pronounce importances of signals. This is, for example, done very often for faint radio signals, or if there is a background noise for audio or visual data, so that we're actually extremely over-amplifying it, and with that the actual signal is getting more pronounced. Then we could create features out of existing data. An example for that could be creating a day of week feature for a weekly pattern out of a date, so that we're not just comparing date or looking at a date, we're actually looking at, is it a Monday or a Tuesday, or is it a Sunday, so that we actually can pick up on this weekly pattern. Then we can create additional dimensionality, which could be, for example, creating a volume out of 3 dimensions. So if we have the 3 dimensions as our features, and we as a human can pick up that those features define a volume, a machine learning algorithm can't not. So creating this feature of volume, now the machine learning algorithm can pick up on it. And then another possibility would be to reduce dimensionality, so we could actually group data by region or group languages by families. Creative approaches to feature engineering. We could combine existing numerical features mathematically, or chaining existing categorical features together. Then we could actually group categories independent of available observations and additional dimensionality. We can create categories based on statistically interfered thresholds values in available data. So, very simple example is a value within the bottom quantile, the second quantile, third quantile, or top quantile. So we can create a category based on that to kind of corsify, categorize the positioning of this value across all the data. Then we can combine categorical features to create a matrix of occurring combinations. Another approach would actually be using machine learning algorithm based on sub-selection of the features as an additional feature in a second stage of machine learning algorithms. The one risk here is that we have data leakage, and with that we would be creating an overfitting in the second stage. So this is something to watch out for. And then finally, a complementary approach to feature engineering: add external data. Find an additional data source and add this to it. In our next part, we are going to be having a look at the demo notebook, where I'm going over a few of the basic approaches to feature engineering on the dataset. See you in the next part.